Hi everybody, welcome to part 3. We're going to look at some velocity graphs and answer some questions about velocity and other particle motion issues from the velocity graph. We should be prepared to work with information given in a variety of ways. So velocity graph, velocity function equation, velocity table, all of those items. So here's a velocity graph. Question is about the acceleration being undefined. Now, in order to answer that question, you need to remember that the acceleration is the derivative of the velocity. So basically, we're asking where this graph, velocity graph, does not have a derivative, or where it is not differentiable. And that's a horrible squishy way to write that. Okay, so differentiability, that's a lesson 10 concept. Things that create a function not having a derivative. Super pointiness is one option. So for example, this super point here at x equals 1, there wouldn't be a derivative there. Okay. The change in slope at 2 would be an issue. And then all of these little sections, these pointy parts at 4 and look at 4 and 5 and 6 are also issues. Notice that we are being asked on the open interval 0 to 7, so we're not having to think about the endpoints. And so I would say, how many times are we not differentiable? How many times do we not have an acceleration? 5. Okay. Change in direction is question 2. Reverse direction. That is a velocity changing sign. When I read a velocity graph, when my velocity graph is above the x-axis, that represents all my positive velocity scenarios. This is all my negative velocity scenarios. Oops, less than 0. That doesn't look like a less than sign. So when does the direction change happen? Just at 3. Direction changes occur when velocity changes sign. Be really careful. Sometimes we like to say direction changes happen when velocity equals 0. That's not true. Velocity equal to 0 is a stop. That doesn't automatically indicate a direction change. All right, so those are the 2 questions on the first graph. Let's take a look at this graph. So we have another velocity graph. We have a point here, and a point here, and a point here, and a point here, all labeled, and then we also have point A and point B on the x-axis. So this is a graph of velocity. Question A is the maximum speed. Well, speed is absolute value of velocity. So the absolute value of each of the y values would be speeds. However, in this case, even if you didn't know that, you would pick the 9 as the biggest number. We would be looking for the number with the biggest absolute value. So if there happened to be a point on here like 7, -10, that speed of 10 would be the biggest one. The lowest speed. Okay. Remember, speed is the absolute value of velocity. So the lowest speed we can ever have is 0. And my speed is 0 at those 2 points. Speed of speed of 2 at the 0, -2 point, speed of 5 at the 6, -5 point. You might need to go back and review that, and rewind and listen to that again. Acceleration is positive. Acceleration, when we're looking at a velocity graph, acceleration is the derivative of the velocity, or it is shown when we're looking at a velocity graph by the slope. So where are my slopes positive? Got to be careful here. The slope is actually undefined at that point. So where you may have wanted to say 0 to 4, the correct answer is actually 0 to 2 and then 2 to 4. My slope is not positive at 2. My slope is undefined at 2. Where is my acceleration negative? Acceleration is negative where my slope is negative, and that will be the entire interval from 4 to 6. Where are my accelerations undefined? At 2 and 4. Those pointy parts. On the interval from 2 to 4, what is my acceleration? Acceleration is the average rate of change of velocity. So I want the slope between these 2 points. 9 minus 8, 4 minus 2, 0.5 or 1/2. Let's shrink this down a minute. We can look at the questions and the graph. 2 more questions relating to this graph. Slowing down, no choices here. Slowing down means that my velocity and my acceleration have opposite signs. Oops. So I need positive y's and positive slopes, okay, because my y's are my velocities and my slopes are my accelerations. So positive y's and positive slopes. Oops, no, I'm sorry, opposite signs. Not speeding up, slowing down. So positive slopes with negative y's. Okay, so y's that are negative with positive slopes. So 0 to A. And then positive y's with negative slopes. So my acceleration is positive, but my change is negative, and that's 4 to B. That'll be something we'll need to talk about a bunch of different times. I know that in physics sometimes you're going to talk about a graph and you're going to talk about like going towards the x-axis and things, some of the things that the graph is showing. We want to convert that to what that means about acceleration and velocity. So we're not going to talk about the graph doing things. We're going to talk about values of velocity and acceleration. Positive velocities and negative accelerations, 4 to B. Negative velocities, but positive accelerations, 0 to A. Okay? I don't want things about the graph is going here or going there. Graphs don't do things, they just sit. They just sit there and look at us. Okay? The graph gives us information about what the velocity acceleration values are doing, and that's what we're going to talk about. Last question, being furthest to the right. This is actually, like I said before, displacement and distance and movement things are going to be more on our next type of discussion of particle motion. But if we think about what's happening here, my velocity is negative and then positive and then negative. So I'm going to move from 0 to A, from time 0 to time A, I'm going to move left. So if this is time 0, the first thing that happens is I move left. And then from time A to time B, I move right. And then from time B to time 6, I move left. There's a little bit more to it that we should talk about, and we will talk about later, but if we look at the amount of time spent moving in the different directions, from 0 to A versus from A to B, 0 to A is a left move, A to B is a right move, B to 6 is a left. So at time B, we are going to be the furthest to the right. Okay. We're going to stop there. You have some additional questions to work on for practice and a free response to work through as well.